Good morning, guys. I don't know, some problem is going on today with the net connectivity or some other technical aspects. I'm just, again, I have established, I have changed my room so that I can get a direct connectivity in my lab. I just get it just from the mobile only, and now I have used the Wi-Fi system. Just hope that it will work and we would be able to learn. See, guys, how hard we're working for you people. So the best thing that you can do to repay this hard work, that you learn. Please, your learning is our aim, and if you are learning, all this hard work will be useful. But if you are not learning, all this will go in vain. So, such a hard work without the electricity, changing one room, two room, three room, and if we are taking the class, please do the value of the thing, right? So I hope now we will learn something, right? And the class will go productive. We will learn something. I'm just making proper setting so that we all can see here. Yes, I was telling you about the purification process, and the process that I have taken, it was the dialysis. Dialysis, it is the phenomena that is based, it is the process that is based on the diffusion, the concept of the diffusion. The principle behind that is that the colloids cannot diffuse, right? Which property, right, is used here? The true solution, it shows the phenomena of the diffusion, but the colloids do not show the phenomena of diffusion. Based on this principle, we use the, right? And what we do here in this case, in the dialysis process, the crystalloid solution, the solution, colloidal solution that we have prepared by the different methods for the stability or for some other reason, we have added some electrolytes. I have shown you on that day when I was using the phenomena of the peptidization. I have used peptidizing agent over there, and that was again a electrolyte, right? So all these things may happen there, all these impurities may be there. To remove these impurities, we use the method of the dialysis. In this, the colloidal solution is hanged in a trough that is filled with the water, right? And the bag is made up of the semi-permeable membrane. This is extremely important thing here, right? The bag in which we take the crystalloid, the solution colloid, this is made up of any of the solution. Now what will happen? Now it is filled with the water. The electrolyte will move out, right, by the phenomena of diffusion. Here, a pure solvent you have taken, the water you have taken, and here is the solution. From its higher concentration, it will move to its lower concentration, and at this part, this will move outside, right? And here the colloidal solution will retain, right? Since this process is very slow, right, for the shape of speedy change, right, for speedily purification, what we can do, we can use the concept of the electricity. And when you use the two electrodes here, whenever you fix the two electrodes here of the opposite charge, what will happen? Definitely the electrostatic force of attraction will also work, and the ions will have the tendency to move towards the opposite charged electrode. The negative ions will move towards the anode or cathode. Negative ions always towards the anode, and the ions always towards the cathode, and this will improve its speed, right? When we were using the pure dialysis theory, in this concept, it was the very slow process, to speed up for the sake of the speed, what we can introduce? We can introduce some modern technology. Here also, we can apply the concept of the electrodialysis, right? Whenever dialysis takes place under the influence of the electric current, right? The electricity under the influence of under the electric field, this is called the electrodialysis, right? So what is the electrodialysis? It is just one improved version of the dialysis. Dialysis is the phenomena, dialysis is the process, right, of removing the crystalloid or electrolytes from the colloidal solution with the help of diffusion phenomena. And for this, it is the colloidal solution is enclosed in the semi-permeable or selective permeable membrane, right? And it is dipped in the water, right? In the case of electrodialysis, the electrodes are used, they are connected with the battery, right? And electrical field is produced here, and the ions present here will move towards the opposite electrode, opposite charged electrode, that will speed up, right? Now the second method of purification of the colloid, I'm just going to explain you, and you are very much familiar with this, and this is the reason why I have compared in my first class of the colloidal chemistry. I have given a comparison between the colloid true solution and the suspension, because only these properties we are using here, right? The next property is the ultrafiltration. This is the next method that is used for the purification of the colloids, right? I have shown you the demonstration of this. I have taken the three solutions. One was the solution of the potassium chromate, other was the starch solution, and the last one was the suspension of the sand. And you have seen when I have poured it through the filter paper, right? The true solution and the colloid, you were not able to separate them with the help of normal filter paper. That's why here we need the method of ultrafiltration, right? Filtration means simply you have to pour your content through the filter paper. But since you know that a normal filter paper, a simple filter paper, it allows both the dispersion medium, dispersed phase, and the true solution to pass across it. That's why it's not very effective method. It cannot be applied for, right? So what we have to apply? We have to apply the ultrafiltration. Here also the procedure is same. The difference is in the filter paper. The normal filter paper that we use, okay, this is dipped with one solution of the nitrocellulose, and this solution is prepared in the ether and the alcohol, right? The normal filter paper, it is dipped in this solution, the solution of the nitrocellulose. Generally 4 to 5% solution of the nitrocellulose is used for this purpose, prepared in the ether or in the alcohol, right? So prepared in the ether and alcohol, this is just dipped into that. Then it is again dipped into the hardening one so that it becomes hard. Now when you pour the solution, right? Now this paper that is prepared by this, although I have set all those things in the lab, but since I have moved because of the net connectivity problem to the next classroom, I could not bring all those things. So the demonstration is not possible today, guys. Sorry for that. Although it was a well-planned class to show you the normal filter paper, ultra filter paper, and the complete procedure that how it is carried on. But okay, some next time whether I will get the opportunity to conduct a practical class, I will do the same. So here, the filtration takes place through the ultrafilter paper, and whenever the ultrafilter paper is used, in that does not allow the colloid to move across itself, right? So in this case, right, what you will observe that the solution, true solution, crystalloid, electrolyte, whatever you wish, you can give the name to that, will pass again on the filter paper, and that you can separate here, right? So this is the guys, right? Actually, the topic that I have taken for today is the properties, but since it was incomplete, so I have taken it. I hope you have understood. It's not a very big deal. If you will read it, you would be able to understand it very clearly, right? Not much efforts are required. Simply it's a theory based one, right? So guys, now I'm coming to the my main point of the today, the properties of the colloid. Some of the properties we have already discussed, some we will take one by one. The first one, that was the nature. It is heterogeneous in the nature, appears to be homogeneous. Right? One word is colligative properties. I hope you have studied it in the solution chapter when the classes were held for the solution chapter. Colligative properties are those properties which depend upon the number of particles. Irrespective to the nature, to the other properties, these properties depend only upon the nature of the particles. 10, 15, 20. This is going to make a difference. It's not going to make a difference whether it is the arsenic sulfide, it is the ferrous hydroxide, or anything. No. What the thing is going to make the difference here is the number, right? As many as viewers are there, they can see it. So this is also one colligative property. So four colligative properties are there in the chapter of the solution. That is the lowering of vapor pressure, right? Then one is elevation in the boiling point. If the normal water boils at the 100, solution boils at the 101, right? That means there is an increase in the elevation. Word simply means the increase in the boiling temperature, right? Similarly, one is depression in freezing point. The ice, it sets at the 0 degree Celsius, but the ice cream, it needs -4 degrees Celsius. So depression in freezing point, and last one is the osmotic pressure. These are the four properties that we have studied as the colligative property, and the most important part of the solution chapter. Always the numericals are asked for these 4 points in the solution chapter, right? These properties depend upon the number of particles. These are the colligative properties. So what do you think? If I compare a solution and a colloid, right, which will show the greater extent of the colligative property? Solution or colloid? The volume is same, right? You have taken the 100 ml of the solution and 100 ml of the colloid, right? Now, which will show the greater extent of the colligative property? Definitely this will be solution, because since the particle size of solution is small, so 100 ml will contain more number of the particles, right? and definitely these properties will be in the higher extent. But colloid, suppose I have taken the 100 gram, okay, this is a 100 gram. If I fill it with these small dots, and if I fill it with these bubbles, right, here only 3, 4, 5 possible, 6 possible. And here so many can be there. And here, since this is, you can equate with the solution, and this you can equate with the colloid, right? Here number of particles are less as their particle size is comparatively greater to the normal true solution, right? So this is the reason always and always the colligative properties are greater for the case of solution, and the decrease is observed, right? A lowering is observed in the case of the colligative properties. The properties which depend upon the number of particles, they do not depend upon the other characteristics of the solute or the solvent. They just depend upon the number of particles. Since the particle size of colloid is greater, right, what you will observe that the number of in the unit volume, right, the number of particles will be smaller here, and here the number of particles will be greater, right? How to write the answer? Okay, suppose one question, this type of the questions are asked in the two categories, either the 2 mark direct question, or there is a question of 3 mark and 3 different definitions are asked. So in this case, how you have to write, the properties which depend upon the number of particles are called colligative properties. In case of colloid, the extent of the colligative properties will be less. Reason, as the size of particle is greater for the case of colloid, the number of particles will be less, right? Definitely, this property depends upon the solute, and here you can say the dispersed phase, right? Here, if you are writing like this, the teacher can come to know that you have the concept of colligative property. Then you can compare it with the true solution. And the lastly, you know the reason also. These 3 points teacher can understand by this. This is the way to write the answer. No need of very long paragraphs, so many words, but content must be. And this is for which we are searching when we are checking your answer sheet. Now, I am taking another point, that is an optical property, right? What it is? It is an optical property, and this is called Tyndall effect. Today, one activity based class has converted into the blackboard based class. Tyndall effect, right? I think you all have gone for the movies. You all have seen the movies. You go to the theater, you watch the movies. This is that you can see there, right? What do you feel whenever the light is passed through a collider solution, right? If you allow the light to pass through the colloidal solution, right, if there is, this is the source of light, what you will observe that there is a bright cone in the path of the light. The path of the light you can clearly see, right? And this becomes broader and broader as it travels the distance. This phenomena, this is called the Tyndall effect, right? Again, this is Tyndall effect, Brownian motion, right? Electrophoresis, these are the keywords of this chapter, colloid. The topic colloid is known for these peptidation, right? All these particular terms you have to learn, right? And always by name of these terms the question is asked. You have to comment on, write the short note or describe Tyndall effect. Likewise the questions are asked. It is the optical property of the colloid, right? The true solution does not show this property. When you allow the light, you just focus a torch on both the solution colloid as well as the electrolyte or a true solution, you will not observe a bright luminant cone in the case of the colloid. But in the case of the colloid, you will observe a bright luminant cone in the path of light. This formation of the bright luminant cone in the path of light, this is called the Tyndall effect. Right? So one part of your question is complete now. What is Tyndall effect? The formation of the bright cone in the path of light is called Tyndall effect. Now the second part of your question comes. Right? What is the reason behind this? Why this happens? Why this phenomena takes place? Right? And the reason behind this is scattering of light. In the sunny days, when in the like nowadays, whenever you sleep in the summer season during the daytime, you just close all the windows and so that the hot air should not come, and a very small slit is there. From that slit you can see the path of light. When you are watching the movie, you just turn your head upwards also, you will be able to see the path of light, the projections that it moves across there, right? This is the example. From the dense plant some light falls there, right? All these are the example of the formation of the helicomet, right? All these are called example of the Tyndall effect, right? The particle size of the colloid is of the range so that the scattering of light can take place. The particle size of solution is so small that the scattering of light is not possible through the true solution, right? So here, what the reason behind is this is scattering of light takes place due to the appropriate size of the particle. Two terms you have to mention when you are writing the answer. One is what is phenomena involved in this, which phenomena is responsible for Tyndall effect. The phenomena that is responsible for the Tyndall effect is the scattering of light. But why this scattering of light takes place through the colloids only? It is due to the size of the colloidal particles. The size of the colloidal particles is of the range that it can go for the effective scattering, right? So these 2 points you have to mention, and the last thing that you have to do here is you have to give the example. This is the way to write these type of the direct questions, right? So this is very important question from the examination point of view. These type of the questions are asked from this topic, right? The formation of a bright luminant cone in the path of light is called the Tyndall effect. This cone is called the Tyndall cone, right? This luminant cone is called the Tyndall cone, and the reason, which phenomena, which property of the light is responsible for this, is scattering of the light is responsible for this, right? So I'm coming to the next property, and this is the charged nature. And so many other properties of the colloids are explained with the help of this nature of the colloid. The colloid overall is the neutral, but its components are the charged one, right? You all have seen, I'm giving you one example, right? Chemical method of preparation of colloids you have seen. If you have to prepare the colloid of the AgI, what you generally do, you just mix the potassium iodide with the silver nitrate, right? And then the AgI is prepared, right? You want to prepare the colloid of the Ag, right? What you have to do, you apply the chemical method for that. And this we have discussed, I think this example itself I have taken on that day, right? Here the concentration of these are also very, very important one, right? Whenever you have done this, what will happen now? The AgI will be here, right? The colloid particles, they have a special ability, right, to be covered, to be surrounded by the particles by any of the ion which is common in this. This may be surrounded either by the Ag plus or by the I minus. This has the ability to attract it. Right now, here the Ag is there. If suppose what is in the excess, if Ki you have in the excess, right, this will be surrounded by the I minus, right? No doubt, the other ion will be in this dispersion medium, right? It's not like that the K will move away from. No, definitely it will remain here. So overall the solution is neutral, but its components are oppositely charged. This is very, very important property of the colloids. Colloids are electrically charged, right? And this can be explained in by the preferential adsorption phenomenon, right? If opposite story I take, I have prepared the solution of the same, and in this case, AgNO3 was in the excess. Right, what will happen here? Again, AgI is our main particle. Right, now this will be surrounded by the Ag plus ion. Definitely, the counterpart will go to the dispersion medium, right? So, overall, it is the negative one, but then also its components are the charged one. So, they behave as a charged system, right? The particles of the colloid are the charged one, right? Sometimes you add the electrolytes to stabilize them. Suppose you have added the KOH, right? You have added KOH to it. This is a fixed layer, right? That is formed around the AgI, right? It is stationary. Now, since here Ag plus is, it will be attracted by the OH minus, and in this case, as it is having the I negative, this will be attracted by the K plus. This is movable, right? This that is added as the protective, and this is the fixed one, right? This is a fixed characteristic. This is as the AGI will be there, wherever it will go with its cloud, right? It is a cloud around this one, right? And this is a fixed layer, right? And since they are having the difference in the charge, that's why it has attraction for this. Similarly, as it is having the Ag plus positive charge, the negative charge is attracted here, right? There is a difference in the potential of this is called the fixed layer, and this one is movable, right? This is movable. The difference between the charge of these two, a very special term that is sometimes asked by the name is called zeta potential. Right? Zeta potential, this is the potential difference between the moving layer and the stationary layer, right? So this is the way how the charge is developed in the colloidal system. The colloidal system is charged one, right? The particles are having the charges there, right? So what you can see, right? There is a difference in the charge. The difference between the charge, this is called the 3 4 points you have to discuss in this question, right? What you have to do, the first sentence that you have to write in this type of the question, that the components of the colloid are charged and overall colloidal solution is neutral. This should be in your answer. Why the charge develops? The charge is developed due to the preferential adsorption theory, right? You have to explain it in the terms of preferential adsorption, right? And you have to express the fixed layer and the movable layer, right? This you have to explain. Then the one word that you must express to make your answer more expressive, more impressive to the teacher, the use the term zeta potential. Right now, its impact. What are the influence of this? Electrophoresis, coagulation, all these phenomena that take place because of the charged nature, right? Whenever I will get the another class, I will take all these topics. Is due to the technical issues, technical interference, the class is short little bit. So because of that, we are not able to complete the topic. Next class, I will continue with all the other topics. Thank you, and please learn and make the best use of your time.